Oh, you're going to totally get this. So differential equations, most of the time we're looking at y equals, well, I'm going to go a little further, and would you circle that y? This is the goal of this unit, is finding y. Almost every time we're trying to find y in terms of x. If you know what y in terms of x is, you've pretty much got the answer. X is still my independent variable like before, but what's different is you have these little y primes and y double primes in the equation. Now, how many of you have seen a movie called The Proposal? Who is in that? Who is in that? Sandra Bullock? Who else? What's the guy in there? The girls always, the Ryan Reynolds is in there. Yeah. So do you remember that scene where they're in Canada and she opens the door and the dog runs out? Do you remember this? The dog runs out, and what happens to the dog? Do you remember? Dog's running out the door, and an eagle comes down and grabs the little, it's a Shih Tzu or something, and takes it away. So this is exactly what differential equations is think of that, look up here, Sophia. You look at the eagle is constantly, as it's flying, it's constantly going toward the dog. The laser focus never changes, but the path does change. And that change of a change is called a differential equation phenomena that we're going to look at. It's called the pursuit problem. But anytime that you're looking at a change within a change, that's a differential equation. Most of the particle changes for subatomic particles uses differential equations. I think Schrodinger's equation is a differential equation. And there's all kinds of places where we use differential equations. So when we look at these equations, we categorize them different ways. F of xy, well, we usually have f of xy, but then we might have a y prime in there or a y double prime. If you stop at y prime, it's called a first order equation. First order is what you and I are going to be doing in the next couple weeks. We're not going to go beyond that. If you want to go to second order, where it has an xy and a y prime and a y double prime, you'll have to join me next year. I just found out this morning that we're going to offer my new class on differential equations where we'll be doing second and nth order differential equations. Brand new, it's just one semester. It'll be second semester next year. Little plug. So we're going to verify. We're not going to solve because that's a lot of math. We're not there yet. But we're going to see if this is, remember I told you the goal was finding y? Let's see if they found the right y equation. Tell me if y is equal to e to the 2x, what's the derivative of that? How's your, nice, 2e to the 2x, good. What's the second derivative going to be? 4e to the 2x, good. Good. So now this tells me if you take the second derivative, which is 4e to the 2x, and you subtract 3 times the first derivative, 2e to the 2x, and you add 2 times y, which is e to the 2x, thank you, this should be true. Is it? Yeah, because you have 4e to the 2x minus 6e to the 2x plus 2e to the 2x. And 4 plus 2 is 6e to the 2x minus 6e to the 2x. There you go. 0 equals 0. So we verified it. But that's kind of what happens with if you go to second and third degree. Once you find that y, it still should satisfy it. All right. So next thing I want to look at are slope fields, looking for patterns in slopes. And it's probably a great place to start is if you get your calculators out. And before you even do that, would anybody know how to find y from this? Been a while. Yeah, do the antiderivative, right? If you know what dy dx is, what's the antiderivative? Turn to your neighbor and tell him what the antiderivative of this is. What's the anti of e to the x? It's e to the x. So what's the anti of 2x? Yeah, it'll be 2x squared over 2, or just x squared. And then what other thing do we add? Oh, yeah, the plus c. That plus c. Kind of annoying, isn't it? Now I want you to use your calculator. Would you put in e to the x minus x squared? Get a visual on what that is, and then I'm going to try to copy it in blue. And when you get it, let me just take a look at it. I can't remember what it looks like. I know it's like cubic, kind of, but it's not exactly cubic. There it is, there it is, there it is. It goes kind of like this, doesn't it? It flattens out here a little more than a cubic would just be here. And it didn't go through 0, did it? Okay. So now what I'm going to do is I'm going to, you can't do this, but I can do this. Not bragging. I can't necessarily do it. No. Oh, yeah. So I'm just going to take these and move them up. 1. Oh, you can do that? Good. Go ahead and put a bunch of these on here. If you can do that, that's great. Don't move them over at all. Just move them down. Maybe it'll work, maybe it won't. Okay. All right, now I'm going to imagine that this is a grid. So this is 0, 1, 2, 3. 1, 2, 3. 1, 2, 3. 3, 1, 2, 3. You could do that on both sides too. You might not go all the way to 3 to get the idea. And if we took, I'm going to just track this quick. The poor people in the computer land have to listen to this. Okay. And now, for each of these points, kind of draw a little tangent to where that slope might be. See how it's different slopes at different places? This is a slope field. It comes from all of the possibilities of that antiderivative plus c. And you can kind of estimate them. You get a little better at it the more you do it. You can kind of see it. What we're going to do is we're going to start with these drawings. And we're going to imagine that these are not here. That this is all you start with, the slope field. You're going to draw these, and then if you can imagine it, you're going to take a point, like maybe this one, and then you're going to kind of follow those slope fields and get a pretty good idea of what that curve was. That's e to the x plus minus x squared plus 0. You good? That's a slope field. Now, let's do it. Let's show you how. That's actually the hard part. This is the easy part, is drawing the slope field. Most differential equations look pretty easy, but they're not. This one looks like, oh, this shouldn't be hard to find the goal, y equals. But because this dy dx is in there, it makes it really kind of nasty. This is saying what's the rate in which you added x plus y. So what we're finding here isn't a y value. We're finding a rate, dy dx. And this formula says that here's your slope, and here are the sum of x and y. We're saying that the sum of x and y is equal to the slope. So I'm going to pick on some points, -1, -2, 0, 1, 2. I think this goes to -3. And then we'll go 1 and 2. We're going to calculate what the slope is and then sketch them. So -3 plus 1 is -2. -2 plus 1 is -1. And you can see the pattern here, 1, 2, 3, 4. -3 plus 2 is -1, 0, 1, 2, 3, and 4. Go ahead and fill those in. And what the meaning behind those is that this formula just said add x and y, but sometimes they might have 2x minus 3y. You could manipulate that to get the slopes. So once you have the slopes, then what you can do is draw a picture. Now the picture is a point is infinitely small, so you can't see it. The slope is also infinitely small slope at a point, but we can make it, extrapolate it on each side to make it a little more easy to visualize. So that's what we're going to do at each point. We know the slope is very tiny at that point, but we're going to just make it look a little easier. So at point 1, let's see, -3, 1, the slope is -2. And you showed me you knew how to visualize slopes. -1 is going to be a little flatter. At -1, 0, it's totally flat. At 0, it's going to be 1, 2, 3, and 4. At -3, 2, it's going to be -1, which is a little flatter. Then it's 0. Then it's 1, 2, 3, 4. It'll be 5 eventually. And so there's your slope field for those. Does that seem okay? Tomorrow we're going to play a game of Smarty Plinko, which you're going to be showing me how to display these slopes on a slope field. I think you'll like that. All right. Oh, by the way, find the y equation going through 0, 1. So let's say we went 0, 1. You draw a point there, and then you just kind of follow what the slopes kind of tell you. I don't know what happens below here, but there's that curve at point 0, 1. So what did we find? What does that purple line represent? The goal, which is finding y. Yep, that's what we did. We found y. And this is a kind of a different way of doing it. That's it. That's all I've got for you. We're going to do a bunch of slope fields. I've got a few here that you can practice. And then we're going to do some together. My goal is that we finish pretty much all of this, and then I'll get the test back to you today.